If you really think that you can find IDOR just by swapping or changing some random numbers and IDs, so you are wrong. It's been more than a decade when IDOR used to be like this. Today I'll break down the anatomy of IDOR step by step. I'm not gonna teach you the basics or the theory part of the IDOR, but here's a quick recap. IDOR stand for Insecure Direct Object References. Most people think IDOR meaning changing the values of some random parameters like id is equal to 1 if you change the parameter value from 1 to 2 so you can get someone other's account's access. That's not totally wrong, but it might be. First of all, you have to understand what is the basic difference between authentication and authorization. Authentication asks who you are, but authorization asks what you are allowed to access. Let's break IDORs into layers. Layer 1, the request. You see a request like this: API order user ID is equal to 123. You logged in, everything looks normal. The backend check only one thing: is the user logged in? But it never checked the most important question: does this order really belong to you? You change the value of the parameter user ID from 123 to 124, and the backend says yes. Now you get the access of the user whose ID is 124, and that's an IDOR. IDOR doesn't crash servers, it silently leaks the data: order, invoice, profiles, documents, sometimes even full account takeover. And that's why IDOR is a critical vulnerability. So, where you can commonly find the IDORs? You can easily find IDORs in the CRUD operations, like creating, reading, updating, or deleting something, or it might be some different endpoints. Since the modern applications don't rely on basic IDs parameter anymore, so attacker don't guess IDs, they observe the behavior. Sometimes an application perform ID verification only once, but allow multiple requests for the same action. In today's modern application, the developers are not using the basic ID parameters. Now they are switched to different hashing algorithms and different verification techniques. Like this, it's a UID, and a lot of developers use encryption and encoded IDs like base64, hash-based references, single token. They look secure, but if ownership isn't checked, IDOR still exists. And a lot of times, instead of real IDs, the backend uses mapped references like file references is equal to ABC123 or order token parameter is equal to some random characters as well. And sometimes developers use session bound IDs. Some IDs are valid only inside a session. But if the backend only check validity, not ownership, access control still fail. Composite identifier like user ID plus order ID or organization ID plus resource ID. If one part is trusted blindly, IDORs happen. Like if the user ID is only the thing that is being checked, the security fails again. And sometimes the developers use role-based object references like role is equal to admin, role is equal to member, role is equal to owner. Depends what kind of roles are available in an organization. So today we saw the anatomy of IDOR, not just changing numbers but missing authorization and where to look for. Yes, IDOR still exists because authorization is skipped, cached or trusted. Remember this, the ID format doesn't matter. What matter is whether the backend checked every request for every user. I hope you understand that the IDOR is not a basic thing anymore. I hope this video helped you a lot.